My guest today is Professor David Lindenmayer, who's professor at the Fenner School of Environment and Society at Australian National University. He currently runs five large-scale long-term research programs in southeastern Australia, primarily associated with developing ways to conserve biodiversity in farmland, wood production forests, plantations, and reserves. Welcome, David.
Thank you very much, Gill.
Yeah, so I got some of your papers. Yeah, thanks for doing this. So I want to start with one of them. It's a recent one, identifying and managing disturbance-stimulated flammability in woody ecosystems. So you say here many forest types globally have been subject to an increase in the frequency of an area burnt by high severity wildfire. Here we explore the role that previous disturbance has played in increasing the extent and severity of subsequent forest fires. We summarize evidence documenting and explaining the mechanisms underpinning a pulse of flammability that may follow disturbances such as fire, logging, clearing, and windfall. Disturbance sometimes initiates a short initial period of low flammability, but then drives an extended period of increased flammability as vegetation regrows. Yeah, so it's a little bit counterintuitive for a layman. And so let's talk about the mechanism here. I'm thinking of forest sort of like it's sort of a biological system, isn't it? I mean, there are a lot of
hmm
different things going on. There are animals, there are trees, there are all sorts of things going on. And so when you disturb it, whether it's by fire or logging, human activities, it sort of makes that biological system unstable. Is that the way to think about it?
Yeah, I think the key thing to think about here is the natural ecological process. So when you have a disturbance, often what you're disturbing is a system that's got seeds in the soil or the potential for trees to resprout. When you log a place, often you remove all the trees and then you either reseed it or restock it with trees. And what happens is that there's a pulse of growth. And that vegetation is generally hotter than it was previously.
Mm.
It's windier, it's drier, and you have this massive biomass that comes up, and it's very flammable until the system starts to age, it matures, it gets cooler, it gets wetter, uh, and darker in many cases as well. And you
Mm.
see this in Western North America, but we also see it in many other parts of the world. So what actually happens is that these forests have this pulse, this period of increased flammability where there's a risk that if
Yeah.
there's another fire, that fire will burn at much higher severity than a fire would burn in a much older forest.
Yeah, that makes a lot of intuitive sense. So it is better to have older, taller trees in the forest. So when you clear them, whether it's by previous fires or logging or whatever, then what is coming up post that? It's going to take a long time for these trees to grow back, I would imagine. So what is coming up post that are things that can get that are very flammable, I guess, right?
That's correct. That's correct. And we actually there was a really interesting concept that was developed in the US. It's called mesification. So the system becomes more mesic, which means it's wetter. And we see that from seminal work by people like Jerry Franklin in the 1980s, other work in the eastern USA in the late 1980s and 90s, and into the 2000s. And we're starting to see similar kinds of work in Australia, but elsewhere in South America and in Canada. So what it basically is showing us two important points. The first one is that as a forest gets older, it tends to get cooler, more shaded, less windy, more stable. These very important microclimates that
Mm.
have a big influence on fire. The second thing that it tells us is that for many of those ecosystems, very, very high severity fire is actually an extremely rare event.
Mm.
It's the natural fire regime, but it's typically very rare. And so this idea then that fire is increasing in the extent and the frequency across the ecosystem is actually changing ecosystems away from that less flammable form to a more flammable form. So then it becomes what we call a positive feedback process, where the more fire we have, the more flammable the system becomes. The more flammable the system becomes, the more fire we have, and it feeds on itself that way. And I think that that's probably one of the key problems that we're seeing in many ecosystems now with these massive fire events. You know, the really tragic ones like we've just seen in Los Angeles and elsewhere, these systems that become very flammable as a consequence of past disturbance. And that past disturbance might be a previous fire, or it might be a logging operation, or it might have been that the system was cleared and now it's regrowing, it's reforesting through natural regeneration, for example.
Yeah, so it's a sort of a runaway process. So as you say, uh, fires bring more fires, and the forest can never recover. It's sort of a runaway process. And so, from an intervention perspective, so I would imagine you could do some mathematical modeling of this, right? We could, I'm just making this up, David, I don't know anything about it, but we could assign a probability of an area, becoming, having some sort of severe fire in the future based on its history, based on its characteristics, based on where it is. And if we can do that, do we have any sort of interventions that makes the situation better?
Yeah, so there's a couple of points there that I think are really important to unpack. The first one is that yes, it is possible to understand. Sorry, sorry.
No
Yes, it is
worries.
possible to understand how this works mathematically, and we see from real data on fires in Australia that the probability of high severity fire increases by about sevenfold, from about
Oh, wow.
10% to 70% for an extended period. It lasts for about 40 years.
Hmm.
And then the curve starts to come back, starting back towards what the system was like.
Hmm.
So that's the first issue, is that, yes, indeed, there's actually a high probability of high severity fire, and it increases substantially. The interesting thing about that, the shape of that curve, is that the risk of high severity fire is almost non-existent for the first 10 years.
Hmm.
And it's not until the forest gets to about 7 to 10 years old that you see this really big pulse of
Oh, okay.
flammability.
Yeah.
And then it starts to come back. And it's not until the forest is about 120 years old that
Hmm.
it resets to that sort of 10% probability of high severity fire.
Hmm.
So that's at the level of what we call a stand of trees, which might be 3, 4, 20 hectares, that kind of thing. So the other thing that's important here to understand is that if you've got lots of areas that have been logged and that are regenerating in a landscape, then the risk of a fire burning at high severity in those patches is very strong. But the
Yeah.
chances that they're going to spill over into the neighboring areas is also very strong.
Right.
And so that means you get spatial contagion of high severity fire across the landscape.
Hmm.
And if you're having repeated fires like this, it means that almost all of the landscape is converted to young forest, which is
Hmm.
very flammable, and it gives you that runaway process, as you so elegantly termed it. And we have a term for that. We call that a landscape trap.
Landscape trap. Okay. And so I'm thinking, David, without knowing a lot about it, I'm thinking, so let's say we can assign a probability. There's a patch of forest. There's some sort of disturbance happened, whether it's logging or previous fires. And we find that, 10 years have passed, and it is getting to sort of a period where high flammability kicks in again. Can we isolate that using some technique, some methodology? It's almost like bringing up a child, isn't it? I mean, the 10-year forest, you got to protect that from 10 to 20, 25, so that it can grow up, right?
Yeah,
For fires to, yeah.
yeah, that's right. So we can actually see with satellite imagery, with LiDAR, other kinds of new tools, we can see the parts of the landscape that are most flammable. And what we can then understand is that if we need to do rapid suppression of fires that are ignited in the system, there are new technologies, drone technologies, sensor arrays, high, very, very high utility drone systems that can deliver payloads of over 1,000 kilos of fire retardant or water to a
Mhm.
pinpoint process, an area the size of a house, basically.
Mhm.
So they're the kinds of places that you might use to do early attack on an ignition, for example, through a lightning strike. And so the engineering departments at some of our universities here in Australia have been looking at these new approaches to deal with fire,
Mhm.
not with these enormous, galumping, sort of massive fire bombers, water bombers. They're going to be important, but actually using very nimble, very fast flying drone fleets
Mhm.
that can detect an ignition very quickly, sometimes within 5 to 10 minutes of a
Mhm.
lightning strike, and then suppress the fire within 10 to 15 minutes with a heavy duty payload. Some of these new drones can fly 500 kilometers an hour and carry a
Mhm.
payload of over 1,000 kilos.
Oh, wow.
So being able to suppress fires very quickly, particularly in those areas of very high flammability that
Mhm.
we've already understood are going to be at extreme risk of being able to break out and spread across the landscape. So
Mhm.
to me, this is a new approach to thinking about fire suppression, using the technologies that are now available. Now, sadly, a lot of those technologies have been used to kill people in recent conflicts,
Mhm.
either in the Gaza or in the Ukraine. But I think about them in terms of our ability to do good, and that is to suppress fires when they're endangering communities or at risk of burning into a mega fire of thousands, if not millions of hectares.
Yeah. And I would imagine there are some correlations between these fires as well. So I'm thinking perhaps some sort of AI applications here too. So suppose you have a set of drones standing ready, and you have some sort of an AI algorithm that can dispatch them when the probability is too high. It seems like early intervention is the key here, right? Once a fire starts, I think it's much more difficult to quell it. Sounds to me.
That's correct. That's correct. So the data also show that the time to control a fire is when it's small, which means very soon after ignition, which means that if your drone fleet is at the right density of drone numbers with the right sensors, and you can fly drones in almost all weather if you know what you're doing, and you don't have to be there on site. You can have somebody sitting in a metal container, you know, 500 kilometers away or 200 kilometers away. You can detect those fires very quickly, very soon after the ignitions. But the other thing that's interesting here is that with mathematical modeling, you can predict where you're more likely to have a lightning strike.
Hmm.
And with that, you can concentrate your work around understanding what are the weather conditions. Is it going to be a dry storm? Are we more likely to have dry lightning?
Hmm.
Where is that lightning strike occurring? Is it in an area of high flammability or lower flammability? Where's my priorities to dispense my drone fleet that's carrying lots of payloads of uh, retardant, fire retardant, or water?
Yeah.
So yes, you can use AI to sort of help prioritize where you'll do your early fire attack to suppress the problem.
Hmm. Is lightning a major contributor to forest fires?
It is in certain parts of Australia and actually elsewhere in Canada, particularly as temperatures increase and we have further instability in atmospheric conditions. There are ways of being able to predict where you're more likely to have fires at higher elevations on certain slopes and aspects.
Hmm.
And if we can marry that with information about the flammability of the forest at the time, then I think we're in a good position to do the extinguishing of fires in that space very quickly.
Yeah, so I'm thinking we cannot do a lot about climate change anymore, as the policymakers have all gone to sleep, so to speak. And so the human aspects here, like logging, for example. Can we create heuristics? I mean, logging is probably a bad thing to do anyway, but then if it has to be done, can we sort of optimally log in some way? I haven't really thought about this, David. I'm just thinking, yeah.
Yeah, that's a good question. And in Australia, what we've discovered is that because the frequency of fire is now becoming so substantial,
Mm,
but it takes a long time to grow a tree to become a saw log to make sawn timber like roof trusses and floorboards and those kinds of things. The period of time to do that is around about 80 years in a
mm,
natural forest.
mm,
But the probability of a high severity fire is so high that there's only a one in five chance that the forest will grow long enough to be able to grow a saw log.
mm,
So that means that you have to rethink where you produce wood so that you're producing wood quickly to grow the crop before the forest is likely to be burnt in a wildfire. And so what we're actually seeing in those cases is we need to go to plantations where we can grow crops of trees very quickly.
mm.
And we know that we can get about 9 crops of trees from a plantation in the same time that we can get one crop from a native forest. So where do we get our wood? It's clearly plantations in Australia,
Mm.
and it's likely to be the same elsewhere. But then we need to think deeply about the design of those plantations to limit the spread of fire across the landscape. And there are ways to design plantations so that we can reduce the risk that the wood crop is going to be lost in a high severity fire. So
Yes,
that's thinking about logging, it's thinking
mm,
about wood supply, it's thinking about where it comes from in the landscape and the design of plantations to give us the kinds of wood flows that we're going to need.
mm. It's almost like farming trees, right?
Mhm.
So I think it's almost like just lost my connection here. Almost like what we have been doing, going into a natural forest and getting wood, appears to have a lot of bad implications. So in essence, we have to go out there and farm trees. It sounds to be right. There has to be a design around that, I would imagine.
That's correct. That's correct. And it's important for several reasons. One is that the return interval of fire is so short now that the risk of losing timber is very high. So we need to go to places where we can reduce that risk. The problem in natural forest as a consequence of past logging is that the elevated fire severity lasts for between 40 and 70 years.
Mm,
So everything that was been logged over my lifetime, over 65 years, is still flammable as a consequence of that logging.
mm.
So now we know this, we should not be continuing to create that problem. We should be moving into other parts of landscapes where we're managing the system better to reduce the fire risk.
Mm. And perhaps some bioengineering is a possibility too, right? So if we can bioengineer trees to grow faster, maybe create the type of wood that we are looking for in a more efficient fashion. It seems to me that the issue comes when people arbitrarily go into natural forests and try cutting down trees without really thinking about the implications of that, right?
Well, that's right. And but the issue here is that the discovery about the relationship between logging and fire really only starts about 2014. There was some signal of that in tropical forests dating back to 2007 to 2008, 2009. But in temperate forests and other forest types around the world, the evidence for that really starts to develop from about 2014 onwards. And then people are finding that was from Australia. Then people were finding similar things in Western USA, then Northwestern USA, and more recently Canada and Patagonia. So this kind of mechanism of changing the forest through disturbance to then make it more flammable with a
Mm,
flammability lag of many decades is now starting to be something that's emerging in many parts of the world, which I think is demanding a rethink of
mm,
how we manage forest ecosystems and where we source our wood, which is from plantations. But if we can intervene in plantations using bioengineering, and also thinking about the end products, glued products, manufactured wood, engineered wood, those kinds of things. They're the kinds of things we're going to have to deal with as part of the problems that are created by the past disturbance of the forest interacting with climate change. Because that's
Hmm.
what we're seeing as well, is that with longer fire seasons, more extreme fire weather, dry conditions, hotter conditions, we've got a very difficult recipe of nasty things going on.
Yeah. And so we see this, as you mentioned, all around the world.
Mm.
Uh, what is the situation in the Amazon, in Brazil and elsewhere? Is it the same?
No, the situation in the Amazon in Brazil is twofold. One is that in many parts of South America, Chile, parts of Argentina and Brazil, there are vast areas of eucalypt plantations, which are very young. Plantations, by definition, are very young. So they're in that flammability stage,
Hmm.
and they're very flammable. Eucalypts are generally very flammable anyway. So we've got a flammability problem in plantations in South America. But in tropical rainforest areas, we've also got problems because of opening up the forest, making it drier, changing in the landscape levels of vegetation cover.
Forests, and whether we can, through technology, essentially build wood in a plantation format, right? So that people don't have to go into forests and cut down arbitrarily the trees that protect them. Where is technology on that now? Do we have technologies to do that properly?
Yeah, there's quite a range of engineered products that are around, and I think that's important. There's also we can select for more fire resistant plant species, which is also important. A third thing I think is crucial in this space is that we've often thought about the need to log forests, and a lot of what we're producing is paper and packaging
Hmm.
from wood products, but we can produce that kind of material from things like hemp that grow
Hmm.
incredibly quickly.
Yeah.
Can be it can be low THC hemp, um, so that there are the other issues associated with those kinds of plants are not there,
Hmm.
and the crop can be turned over in a year. So it can grow very quickly. Long fibers, very important for paper and packaging products, can be blended with other kinds of recycled materials.
Hmm.
So I think we need to expand our horizons into solving some of these problems. What are we actually growing the wood or the plants for? What's the end product? Can we make those end products in other ways that that really get us to where we need to get without creating all of these additional flammability problems, which are clearly arising.
Hmm.
That the flammability issue is an increasing one. Canada just lost 12 million hectares of their forests. We
Wow.
lost 2019-20, we lost 12 million hectares.
Hmm.
So large parts of Los Angeles burnt. There are fires in the Arctic. There are fires in Greece, in Spain. Portugal loses more of its wood production forest, which is mostly plantation, than any other place in the world. And
Hmm.
we're looking at some pretty serious problems here.
Yeah, it almost sounds like a material sciences problem to me. So, I mean, we have taken material sciences based technology into a lot of different areas. Computing, manufacturing, building, construction. So wood, in some sense, has been with us for a long time. It's probably time to rethink if we need to have wood the way that we've been trying to get them. It's an easy thing to do, but it has long-term really bad implications, right? So, can we bring some sort of material science innovation into it? We are making artificial burgers, artificial meat now.
Mm.
We should be able to make artificial wood, I would imagine.
I agree totally. I agree totally. And to me, it's like the difference between um, instead of using candles to make our light, we use electricity as a transition of materials, as you say. And here we see the consequences of converting old forests to young forests is a serious problem. Let's rethink the kinds of materials that we want to make products from, because by and large, our forests are more important left standing than cutting them down. They're
Hmm.
more important for carbon storage, for the production of water for our cities and human consumption, for the protection of biodiversity, from the
Hmm.
maintenance of rainfall patterns for our environments. We were talking previously about the Amazon and the problem that's happening in the Amazon with logging there that is changing the environment. We need to be mindful that the average rainfall drop falls 5 times in its
Hmm.
passage from the start of the Amazon to by the time it reaches the sea. And forest is a really important intermediary in that, recycling that water into the atmosphere so that it's reprecipitated and that cycle goes on. So, these are fundamental processes and of how the world works. And if we take forests out of that, then we're going to be in serious trouble. So I agree totally. A rethinking of material science is where we need to be at.
Yeah. And from a policy perspective, it seems to me that people sort of gravitating toward this is a climate problem, and there isn't a lot one could do. And so I think your focus has been sort of looking at the intersection. I mean, climate is a problem, we know, but it's the intersection of climate and human-based activity that's making the problem much worse, right?
That's correct. So what we're seeing is that the conditions for wildfires are increasingly a problem. So it's drier in many parts of the world. It's it's hotter in many parts of the world, so the evaporation rates are much higher. So we're seeing extended fire seasons. We're seeing an increase in the severity of fire. And the six most severe high severity events have been in the last 5 to 6 years. And some of the largest fires ever recorded on the planet have been in the last 5 to 6 years. And so there's that intersection of climate and fire behavior and fire weather, but then our actions in disturbing forests is also contributing to that problem. So we've really got a nasty alignment of very difficult things.
Mm.
Plus, we've built a lot of our cities in areas that are highly fire prone and becoming increasingly so. So this is where the technology for rapid fire suppression becomes really important, so that we can allow systems to be able to move back towards a less flammable state over time.
Is there some sort of tactical policy intervention? What I mean is, material science innovation is going to take time, but tactically, can we do something? Can we have a policy that says, if you were to log, you have to do it in this specific areas or something like that? And I'm thinking about some sort of optimization in the logging scenario. Is that possible?
Yeah, I think it is. I think first, as we discussed earlier, the importance of moving our wood production into plantations is crucial. In some places that can happen almost immediately because most timber already comes from plantations, like in Australia. But and in New Zealand they made the transition 22 years ago. They're
Hmm.
completely in plantations only. So there's that longer term process in some countries, but a short term one in others. At the same time, yes, there'll need to be native forest logging going on in some places, natural forests continuing to be logged, but maybe we should move that away to be more remote from where people and property occur. And
Hmm.
that's part of thinking in the short term, where should we not be logging? But and then the long term, how should we change to logging plantations rather than natural forests? And also, what are the materials that we can use to make our paper products and packaging rather than natural forests? So
Hmm.
there's some short-term things. The other one is equipping ourselves with the technology to be able to extinguish fires very, very quickly. And that is crucial, to be able
Yeah.
to adopt those technologies that are already well entrenched in defence and the military industrial complex. Let's move them across into the natural environment to help us with nature-based solutions to this flammability issue. but
Mm.
it's also a nature-based solution to the climate issue over time.
Right. Is the demand for wood decreasing worldwide? What is the trend?
The trend is that it's increasing,
It's
but the
increasing.
proportion of that increase that's now covered by plantations is increasing dramatically. Um, what originally happened was that at various stages, the demand for cheap pulp to make paper
Mm.
was declining, but now with population growth, that is increasing. And there is also a demand for wood products for building and the like. But this is where engineering products can come into place through
Yeah.
engineered wood, and they're often lasting much longer, and they're actually more reliable materials than natural wood. Uh, it, Certainly, in many places, the average lifespan of a timber product is less than about 30 years, because
Mm.
that's the time that it takes for people to build a house and then 30 years later renovate that house.
Mm.
Now, the wood products that are turned into paper and packaging, somewhere between 6 months and 3 years lifespan in the carbon life cycle.
Mm.
And that's a large part of our wood product consumption.
Yeah. Yeah, I know that we are still building wooden homes here in the US. My home here in the northeastern part of the country is 1960s. It's all wood. And a lot of the homes still built with wood. I grew up in India. They hardly ever build anything with wood because it just can't sustain itself. So it's mostly concrete and steel. And so there is sort of a cultural transition here too, right? Yeah, what's the situation in Australia? Are you guys building homes with wood?
So the situation in Australia has been quite interesting. Over the last 10 to 20 years, the proportion of wood products that are sourced from plantations has has declined from I think it's around about 10 cubic meters per house
Hmm.
now to less than 1 cubic meter per house on average. And the vast majority of wood is actually sourced from plantations,
Okay.
particularly Monterey pine or radiata pine. And that's because the timber is more reliable, and it can be treated in ways which makes it more termite proof and more stable. So it's used for floorboards and roof trusses and some of those fundamental parts of your house. And then there's a lot of other engineered wood products that are not based on natural timbers, but are re-glued to give a little veneer, those kinds of things. So in an Australian context, roughly 90% of the country's sawn timber products
Hmm.
that are used in houses and building already comes from plantations. And some of our states, such as the state of South Australia, that's been the case for over 100 years.
There's a growing plantation also has an environmental benefit, right? So there is, sort of carbon being taken up. But I wondered, is there scale in plantations? Would you consider, I'm thinking of Africa, for instance. Can we go into a barren land and create a plantation?
In some cases, definitely yes. It takes a lot of tending to do that. In some cases, there's a background of weedy grasses and fire regimes that need to be dealt with. But often there are places where there's good opportunities to establish plantations or allow natural regrowth to take place. So there's quite a bit of science looking at land capability and its ability to the ability of that land to support plantations and forests. And that's in Africa, South America, parts of the US, extensive parts of Australia. So from in my own area, there's about 19.9 million hectares of country that's presently cleared that has potential to be regrown as plantations. Now they can be wood plantations, or they could be things like hemp and hemp fiber for producing paper and packaging. So there's a big opportunity there. It does have implications, because if you change from standard agriculture to
Mm.
plantations, it changes the social fabric of a landscape.
Mm.
It changes the number of people in the landscape. And it also has implications for food production and fiber production, for example, from livestock.
And you cannot mix them typically, I would imagine, right? These are specialized. A plantation cannot really mix with food production, I would imagine, right?
Well, it depends on scale. So in places, for example, in southern Sweden, there's some very good examples of the integration of agroforestry. So you can have areas where you have tree plantations in wood plots on a farm, and then the remaining area might be canola crops or wheat crops, those kinds of things. So it's an integration process at scale. So there's quite a lot of work in that space.
Mm,
Similarly, there are farms now in Australia that are what we call agro-solar. So we have solar farms with extensive panels. The
mm,
panels provide shading for livestock, and there's grass that grows under the panels. So you get energy production from your solar panels. You get a wool clip, or you get fat lambs that are produced from that area.
mm.
Uh, so, there are interesting integrations of different land uses in the same area. So, I often think, gosh, if we can put a human on the moon, we can solve these problems. They're trivial in
Yes.
comparison.
Yeah, but this is a complex system problem. So my intuition is that given an engineering problem, we'll solve it. Given sort of a complex system problem, we seem to fail in that typically. And this is in the latter category, I think. But you've been doing research in this area, David, for a long time. Are policymakers understanding this? Are they listening to you?
At times, yes, and at times, no. And that's because at various stages, evidence becomes useful, and at other stages, people don't want to hear. I think we can see that in the political landscape that's occurring in your country at the moment. Um, but there are times when the economics of it changes things dramatically. So in an Australian context, what we see is that our native forest logging industry is a loss maker, and a very substantial loss maker, in the realm of billions of dollars
Hmm.
annually. And the financial success story is actually in the plantations, and it's because it's growing sawn timber, whereas our native forests are growing largely wood chips and paper pulp, which
Hmm.
is a loss maker. So the industry imperative is actually for the transition, because economically it's not sustainable to keep forking out hundreds of millions of dollars every year to prop up an industry
Hmm.
that's not financially viable, but at the same time adding significantly to this fire burden. The more we log the forest, the more flammable it becomes. The more flammable it becomes, the more likely it is to burn. The larger the areas that burn, the bigger the cost to the economy of the fires. So our
Hmm.
2019, 2020 fires in Australia cost the economy in the region of about $100 billion.
Hmm.
And we just can't afford to continue to have those kinds of fires year on year.
So in conclusion, David, where do you want to take this research? I know that you're involved in some large studies right now. Um, what do you think you will find further from what we discussed, and how do you want to, where do you want to take this research from a policy perspective?
I think we have to now make it quite clear to people that we are making forests much more flammable, and that we need to embrace new technologies to solve that problem. And we need to embrace new things such as material science to create alternative feedstock streams to make the wood products that we've been making from native forest wood. So the transition needs to be towards plantations, maybe not just of radiata pine, but other things like hemp, and at the same time develop new industries around rapid detection, rapid suppression of fires to be able to move these forest systems much more across into a lower flammability state from the high flammability state that they're in at the moment.
Yeah, I mean, it's also an innovation space, right? If somebody can figure out artificial wood, that's a pretty interesting product.
Yes.
that could have interesting economics. So maybe private investments could
Yes,
could come into it.
I think there's a huge opportunity for private investment. I think there's a massive opportunity for investment around the new technologies in firefighting uh, and in material science, but also in landscape design
Yeah.
and assessing landscape risk so that if we do have multiple lightning strikes at the one time, which ones do we prioritize to
Mm.
extinguish first so that we can reduce the risk of high levels of spatial contagion of the fire?
Excellent. Yeah, this is important research, David. Sorry about the technical difficulties. But yeah, thanks for spending time with me early in. Are you in Sydney? Where are you?
No, I'm in Canberra, the
In Canberra.
capital.
Okay.
Yeah, good. And
Excellent.
whereabouts are you?
I'm in Connecticut. I'm between New York and Boston.
Yeah, right. Yeah, that's a nice part of the world. I lived in Western Massachusetts for 6 months.
We have no forest fires here, fortunately. It's all in California.
Yeah,
But as you know, our president has some great ideas how to solve forest fires. So we'll see. We'll see if it
yeah.
works. Yeah.
I don't think let's not go there. Okay.
Excellent. Yeah.
Thanks,
Go
Gil.
ahead. Sorry.
Cheers.
Yeah.
Bye.
Thank you.